Good day, learners, especially to all the public junior high school students. Welcome back to iLearn channel. We are now in the second quarter and we will focus our topics on physics. Our most essential learning competency is to compare the relative wavelengths of different forms of electromagnetic waves. Here are the things that you should learn today. First, define electromagnetic waves. Second, trace the development of electromagnetic wave theory. Third, describe the transmission and propagation of electromagnetic waves and discuss the properties of electromagnetic waves. But before we discuss, please subscribe and hit the notification bell for the next video updates. Thank you very much. For our first activity, let us define what an electromagnetic wave is. Electromagnetic waves are all transverse waves that propagates outward from a source perpendicular to the direction of the wave's travel. As you can see from the illustration, a transverse wave is compared to a rope that moves up and down, perpendicular to the movement of the wave. Perpendicular means that the motion and direction of the waves are at 90 degrees angle. The creation of all electromagnetic waves begins with an oscillating charged particle. Charged particles refers to the protons and electrons, which creates oscillating electric field and magnetic fields. These waves illustrates the magnetic field, and this one illustrates the electric field. Electromagnetic waves do not require a medium to propagate. Medium refers to the solid, liquid, or gas particles. They travel in any medium, even in an empty space called vacuum. So in a vacuum, there is no presence of any matter. They travel at a constant speed of 3 times 10 raised to the 8th power meter per second, or 300 million meter per second. Electromagnetic waves possess different velocity of propagation in different medium. When traveling between media, the wavelength, the speed, and the frequencies also changes. Electromagnetic waves travel fast in gases compared to solids and liquids. The electromagnetic spectrum is a sequence of all electromagnetic waves arranged according to the frequency and wavelength. As you can see from this illustration, from this point to this point, we call it as wavelength. The wavelength decreases from left to right and increases from right to left. On the other hand, the energy and the frequency increase from left to right and vice versa. For our second activity, we will identify the 7 types of electromagnetic waves and their application. These are the 7 types of electromagnetic waves. First, radio waves. Second, microwaves. Third, infrared. Fourth, visible light. 5, ultraviolet. 6, X-rays. 7, gamma rays. Now, let us try to compare the relative size or range of each wave from the following illustration. Building, atom, molecules, honeybee, pinhead, human, and bacteria. Alright, let us click this. So it is a building. So the size and the range of the radio waves is compared to a building? How about microwaves? Human. How about infrared? A honeybee. How about gamma rays? It is compared to an atom. How about X-rays? A molecule. Ultraviolet, a bacteria, and number 4, visible light. It is compared to a pinhead. Another question, do we need electromagnetic waves in our daily lives? Yes, of course. Here is the application of electromagnetic waves. Let us identify the type of wave these applications refer to. Let us start with the radio waves. The radio waves is used to broadcast radio and television. Microwaves is used in cooking, radar, and telephone. Infrared transmits heat from the sun, fires, and radiators. Visible light make things able to see. How about ultraviolet? Absorbed by the skin, used in fluorescent tubes. 6. X-rays, used to view inside bodies and objects. How about gamma rays? Used in medicine for killing cancer cells. For our third activity, we will study the people behind the development of electromagnetic wave theory. Let us recognize them one by one and identify their contributions. Let us start with him. First, to discover the electromagnetic induction, the production of an electric current across a conductor moving through a magnetic field. Who is he? He is Joseph Henry. How about him? He was able to perform many experiments that helps explain reflection, refraction, polarization, interference, and velocity of electric waves. Who is he? He is Heinrich Hertz. He formulated the concept about photoelectric effect. I think you know him. Who is he? He is Albert Einstein. How about this one? He discovered that the Earth was magnetic and theorized that electricity and magnetism are not the same. Who is he? He is William Gilbert. He described how electric charges and electric currents act as sources of electric and magnetic fields that form the basis of electrical field of science and technology. He is James Clerk Maxwell. He discovered that an electric field that flows through a wire creates a circular magnetic field. He is none other than Hans Christian Ørsted. How about this person? He discovered that the ratio of electrostatic to electromagnetic units equals the value of the speed of light, leading to the conjecture that light is an electromagnetic wave. He is none other than Wilhelm Edward Weber. And the last person, he developed Coulomb's law, which defined the electrostatic force of attraction and repulsion. Who is he? He is Charles Augustin de Coulomb. So, these are the people behind the development of electromagnetic wave theory. I hope you recognize them and their contributions. For our last activity, let us study how electromagnetic wave was transmitted and propagated. So we use electromagnetic waves in communications, as you can see from the illustrations. There are three types of transmission and propagation of electromagnetic waves. The first one is ground wave propagation or surface wave propagation. The second one is the skywave propagation or ionosphere wave propagation. And the third one is space wave propagation or tropospheric wave propagation. Let us discuss them one by one. The ground wave propagation. It is a method of radio frequency propagation that uses the area of the Earth and the ionosphere for transmission that can propagate at frequencies below 3 MHz. This happens when the electromagnetic waves propagate and travel along the surface of the Earth towards the receiver's antenna, just like this. Local radio communications such as AM, FM, and television broadcasting. One-way communication for military to submerged submarine is an application of this transmission. How about this one? Skywave propagation. It refers to radio wave propagation via ionosphere. This happens when electromagnetic waves travel towards the sky after propagation and reflect to the Earth from the ionosphere. Long-distance, point-to-point communication. How about the last one? Space wave propagation. It can travel directly or after reflecting from the Earth's surface. It can travel directly or after reflecting from the Earth's surface to the troposphere surface, from the transmitter antenna to the receiver antenna. This happens when the electromagnetic waves are propagated from the transmitter antenna and it travels in a straight line without any reflection or refraction. Used in television and radar communications. Extremely long-distance communication using multi-hope propagation. Alright, iLearners, I hope you learned today, and please don't forget again to subscribe my channel and hit the notification bell for the next video updates. Thank you so much for watching, and goodbye!